Okay, so assignment number 5 is dealing with vertical curve calculations, and here's the Canvas page with that assignment, and there are 3 PDFs on that Canvas page. The first PDF is sort of a cheat sheet for that vertical curve math, and that looks something like this. So here's that cheat sheet. And the first thing we want to look at is for vertical curves in road design. Those are going to be parabolic curves. And so that follows the typical formula for a parabola, which you may have seen before, or you might recognize this. And each of these components, so this is the formula, the general formula for a parabola, and each of these components is tied to that curve in some way. So we're going to ignore this for right now, this x low or high. But let's look at this first component, a. So a, here is how we can calculate that variable a. And then b has a component here. This g1 is the same as the variable b. The variable c is going to be the elevation that we start our curve, so the elevation at the beginning of the vertical curve, and then that variable x that shows up a couple times, so x squared, and then over here we have x times b, and x is the length along the curve that we're talking about. So let me pull up another image here. So this is the second PDF on the right of the screen here. This is showing a vertical curve, and again I've shown some of that formula here on the curve sheet. And then the third PDF is the worksheet itself, and I'm asking you to fill in what shows up in green here in Excel. And here we've got different elements. So starting at the beginning of the vertical curve, the BVC, and that corresponds to this point on the drawing. So you can see the beginning of the vertical curve is at station 3 plus 0. So there I show 3 plus 0. And we have an elevation at that curve point. So here is the elevation. Now I can calculate an elevation at any point along this curve if I know how far along the curve we're going. So we need the length along the curve, that's our x value. Now don't confuse x and L. L is the length of the curve overall, the total length of the curve, and that does not change. That is going to be the same length for all of our calculations. And what is the length of that curve? Well, if I start at station 3 plus 0, 0, and I end at station 12 plus 0, 0, then my curve must be 900 feet. That's the total length of the curve. So 1200 minus 300 gives me 900 feet in between. I know the slope coming in, we're at negative 5 1/3%, and then the outgoing slope, we're a little steeper, positive 9.17% approximately, and that's all the information that we need. So I'm going to start by calculating some of these components. Now, the curve math sheet that gives all the formulas, I've shown the formula a couple of different ways. So here's in terms of y and a and x and b and c. Y, by the way, this is our elevation. That's our payout. And you can reverse that formula around. So our elevation is equal to the elevation that we start plus this multiplied variable. So b, what is b? Well, that's our grade 1. That's our incoming slope. So b is our incoming slope, or g1. And I'm going to start filling in that information here in Excel. So g1, there's my negative 5 1/3%. And when we're doing the math, we have to express that as a decimal, not as a percent. So I've changed this to a decimal. Same thing with g2, or our Our final slope, our outgoing grade, that is 9.167%. And again, I want to show that as a decimal, so 0.091667. That's our outgoing slope. And that's going to let us figure out variable A. So if I'm trying to fill in all of the components of this formula, then I need to figure out what component A is. And A is this thing right here. So our outgoing slope minus our incoming slope divided by 2 times the length of the curve. So the length of the curve, L, again, that's 900 feet. And so 2L, well, that must be 1,800 feet. I'm just putting these over here so I can use Excel to do the calculations for me. And then, again, incoming grade, outgoing grade. So the variable A, well, that must be grade 2 minus grade 1 divided by 2L. And that gives me this very small decimal. And so I'm capturing, looks like I've got 7 decimal places there just to get enough significant figures. And eventually I'm going to need 2A for calculating where our high or low point is. So I've also included that here. So 2 times this value A gives me this small decimal. So I'm going to start filling in this chart based on the information that I know. So variable x, that's how far along the curve are we going from our starting point. So at the beginning of the vertical curve, we are going 0 feet in the x direction, right? We're not moving in the x direction at all. We're staying right here, so my x value for that first station is going to be 0. At station 4, well, I've gone 100 feet along that curve. So that'll be my input for x, the length along the curve. At station 4 is 100. At station 5 plus 0, 0, I have gone 200 feet from the beginning of our curve. So here at station 5 plus 0, 0, that's 200. And notice all of these are going up in increments of 100 feet. So my x must be increasing by 100 feet until I get to 900. So I can fill that in pretty easily. Now value A, so here's that component A, that's my outgoing grade minus incoming grade divided by 2L. And that's the total length of the curve times 2. And so this thing, that does not change either. That is the same number throughout. So I'll just type that in. Oops. Right here in my column A, 0.123400806. And then it did round, and I'm just going to copy that value in all of these cells because A does not change. I'm going to skip this column for a second, and I'm going to go to the B column. So B is equal to grade 1, our initial slope. And our initial slope does not change. That's always this negative 5.333%. So I can just copy that and paste that in my B column. And that's going to be the same throughout. And column C, I'm going to skip this one for now. Column C, where is C? C is, let me go back to the vertical curve math. So C is the elevation at the beginning of our vertical curve. And that does not change. The elevation at the beginning of our curve is always 100 feet. So I will input 100, and I can just copy and paste that all the way down. So we've got most of this filled in already. Now I can get my last 2 columns for bx and ax squared. So I'll do bx first. So that I'm going to use Excel formulas here, but you could use a calculator. So essentially I'm taking this B value and I'm multiplying it by the X value. So in this first box here at station 3 plus 0, well, my X is 0, so anything multiplied by 0 is going to give us 0. And here in the AX squared column, I have A times x squared, and if x is 0, then x squared is 0, and a times 0 is going to be 0. And so I'm just going to do a double check here. If y, my elevation, is equal to ax squared plus bx plus c, then in this case I have 0 plus 100, and that gives me 100. So there's my double check. I know I'm on the right track. Now also notice this is a sag curve. We're going to be going downhill to our low point, and then we'll start going uphill again. So my next value here, 100 feet along the curve, I should see something less than 100. So let me go through and start filling in these columns. So bx, that cell is going to be equal to b times my x. So there's my bx. And this ax squared column is going to be equal to my a value times x, and then I'm just going to say times x again. That's the easy way to do it in Excel. So I have an ax squared, I have a bx, I have a c. I'm ready to calculate my elevation. So my elevation is equal to ax squared plus bx plus c. And now I've gone downhill from 100. And without knowing anything about this curve, the only thing I know is, well, I'm going downhill and it's a sag curve, so I think it's right. I'm going to continue on here with this next station at station 5 plus 0, 0. I'm going to calculate my b times x. So that cell is equal to b times x. And then my ax squared is going to be equal to a times x again. Now I can calculate my elevation, my y, that's equal to ax squared plus bx plus c. And I'm continuing downhill, so I think we're going in the right direction. I'll do a couple more of these. So bx column is equal to my b value times my x value. And be sure that if you've got a negative slope, make sure you include that negative symbol here. Otherwise you will have the wrong values. So just double check that you've got a positive or negative slope. So in my ax column, that's going to be equal to the value a times x again. And there's my ax squared value. So my elevation is equal to ax squared plus bx plus c. And I'm still going downhill. So now that I've established a pattern with these cells, this is the handy thing about Excel. Here I've established a pattern, and I'm just going to drag that down for both of those columns. And we'll see if this is giving us the right value. Doesn't look like that worked, so I can't do the cheat. I'll have to continue inputting these cell values manually, so I'll do that here. Equals a times x. This is equal to a times x. I'm just going to go right down the line here. Equals a times x. A times x. So a couple more cells here. So there's my ax squared column. Bx column should be pretty quick. Equals b times, b times x equals b times x. almost done, 2 more cells, equals b times x and equals b times x. So there I've got all my columns filled in. Now I can calculate my elevation. So equals ax squared plus bx plus c. And here now I see we are going back uphill. So my low point is somewhere between station 5 plus 0, 0 and 7 plus 0, 0. So ax squared plus bx plus c equals ax squared plus bx plus c. 2 more to go. Ax squared plus bx plus c equals ax squared plus bx plus c. And it looks like my elevations go downhill until I hit the low point, then I keep going uphill. And again, without having known values here, all I can say is they look like they're going in the right direction, so I'm going to believe those values for right now. So this last portion here, I can figure out where exactly the low point or high point in my curve happens, and I can do that with this formula right here, negative b over 2a. So the x, so I'm solving for x, where on my x-axis does that happen? That happens where negative b divided by 2a, that's going to give us some distance in x. So I'll say x, in this case low, is going to be equal to, and I'll use my parentheses to be careful, I want the negative value of b. So where's my b? That's the same as my incoming slope, so negative, negative. I see what's happening here. I forgot my equal sign, so that cell is equal to, a couple of parentheses, negative 1 times my b value divided by 2 times my a value. So fix my parentheses, 2 times the value of a. Close my parentheses. So there is the x at my low point. So x, the low point happens 331.03 feet beyond the start of our curve. So 331.03. Now with that x value, I can start calculating some of this other stuff. Remember this, my a value does not change, so a is going to be the same. My b value does not change, that's going to be the same. C value does not change. So I have a bunch of info here. Can I do my bx column? I have a b value, I have an x value, so yes, I can do this cell here for bx. That's going to be equal to my b value times my x value. And now ax squared, that's equal to my a value times my x value times my x value. So I have all that information. So I know where in the x-axis that low point happens, 331 feet beyond the start of our curve. So somewhere in this region, about a third of the way along our curve, that's our low point. But what is the elevation there? Let's find out. The elevation at that low point is equal to ax squared plus bx plus c. So my low point, 91.18, and you can see that is the lowest value showing up on the chart here. So again, without knowing the actual value, I can say the numbers look like they fit. That works also for a high point. If we have a crest curve, then we could calculate where that high point happens using the same formula, this negative b over 2a. That will tell us how far along the curve it happens, and then we should be able to calculate everything else. So what is the station at that low point? That's going to be our starting station plus the distance beyond our starting station, which would be 6 plus 31.03. So that's the first worksheet. We worked through this one in class. The second worksheet is available for you on Canvas. So work through that to the best of your ability. And if you have questions, contact me on Teams or email, and we'll work through it.